Hello everybody, in this lecture we will be solving 1997 IMO problem number 2. Here is a view of this problem. The angle A is the smallest of the triangle ABC. Angles B or C, one of them can be greater than 90, that's not a problem. The points B and C divide the circumcircle of the triangle into two arcs, namely the minor arc BC and the major arc BC, and we are told that U is an interior point in the minor arc BC. So let's say, let's pick U somewhere here, I guess, U. And the perpendicular bisectors of AB and AC meet the line AU. So let's first go ahead and draw the line AU, something like that. Okay, and so the perpendicular bisectors would be something like this. So I just draw a 90 degree, like that. So it would hit this point here at the point V, and similarly the perpendicular bisector here, something like that. So that's a 90 degree angle, obviously. Similarly, this one is a 90 degree angle, and that point here is W. And finally, we are told that the lines BV and CW, so let's use another color here. So we have the line BV, something like that, and CW, something like that. They meet at this point here, the point T, and we would like to show that, so this is the point T, and we would like to show that AU is simply equal to TB plus TC. So let me go ahead and make this picture larger, and I still keep the question on my screen. I think that's reasonable like that. If we look at the angles, well, obviously angle A is the smallest, right? So angle A, we are told, is less than both angle B and angle C. Then secondly, because we have perpendicular bisector of AB here, these two are the same, so it is obvious that triangle AVB, and similarly triangle AWC are isosceles triangles, and as a result, this angle here would be simply equal to this angle, and similarly this angle is equal to that one here. So that's obvious. At this stage, I would like to make the following observation. I will go ahead and extend the line CW, in fact. So let's extend it, and the point where it hits the circumcircle, let's call it X, and let's connect it to the point B of our triangle. Something like this, actually. Let's just clean this mess. Okay. And then if you consider the angle here, angle BXC, angle BXC is obviously equal to angle A, or angle BAC, right? Because they both subtend minor arc BC. Now recall that AC is a chord of the circumcircle of triangle ABC, and it is no surprise that the line, the perpendicular bisector of AC will eventually go through some, this point here, which is the circumcenter, right, where the two perpendicular bisectors of two chords meet. So that point is O, is the circumcircle of our triangle. But what I'm trying to say is that because triangle AWC is isosceles, and you have this chord AC, which is so symmetrically situated with respect to the circle. Well, any chord is like that, but what I'm trying to say is that the distance AU is equal to CW, right? So in fact, so AU is equal to CW as well. Sorry for that. So CX, I should say. Sorry, CX. But I hope that's clear, right? So this is due purely to the symmetry, the perpendicular bisector of AC being going through the point, through the center of our circle, and the triangle AWC being isosceles guarantees that the length AU of the chord AU and the chord CX are basically equivalent. But then the problem reduces to, instead of showing AU being equal to TB plus TC, so AU being equal to CX, therefore all we need to show is to show that this is equal to TB plus TC. So we need to show this. The crux move now is to observe that if you focus on triangle XTB, we have already established that angle BXC is equal to angle BAC. But then, if you also focus on angle XBA, you just realize that this angle subtends arc XA, minor arc XA, but that arc is also subtended by angle XCA. So these two angles are the same. So angle XBA is equal to angle XCA, but then that would imply that angle XBT is, which is equal to angle XBA plus angle ABC is sorry, ABT, I should say, sorry for that, ABT. But notice earlier so XBA is just XCA plus ABT is simply the same thing as ABV, angle ABV. Now XCA we established early on was equal to CAW, so this is angle CAW plus an angle ABV is the same as angle BAV, implying that angle XBT is nothing but angle BAC as well. So therefore, in triangle XTB, both angle BXC and angle both angles BXT. Let me write it down here. So angle BXT is equal to angle A, which is also equal to angle XBT, suggesting that triangle XTB is in fact an isosceles triangle, and as such XT is equal to BT. So therefore we wanted to show this claim, but notice that TB can be replaced by XT, and you just keep the TC here, but that's obvious. XTC is just a straight line, so therefore XT plus TC is nothing but XC, as we wanted to show. And that basically solves this very easy IMO problem. Hope you enjoyed the video, and looking forward to see you guys in our next lecture.